Hello, grade 9s, and welcome back to the world of learning, our first e-learning lesson. We're going to pick up pretty much where we left off before March break. About a week before March break, we had finished the unit on solving equations. This is a little refresher. What I have right here is an equation. There's only one variable. The one letter is the x. We know the objective is to figure out what number x really needs to be to make this statement a true statement. And so remember we used distributive property to open up the bracket. And then the object, of course, is to get x by itself. So we begin by collecting like terms to make it a little tidier. And then we want to transpose, to throw the 1 to the other side, which we do by the opposite operation, not the opposite sign. Subtracting 1, adding 1. We get 2x is 10. Notice here the 2 is being multiplied by the x. The opposite of multiply, divide. And I get x equals 5. So when you only have one variable, you can actually solve the equation, figure out what the one and only number in the whole world that x could possibly be to make this true. And in this case, that number is the number 5. But in this unit, we're going to move forward and we are going to look at equations in two variables. Notice x plus y, 2 letters. Over here, we have x minus y equals 8. So these are equations in 2 variables, and we're going to learn how to solve these equations. And of course, we're going to study these equations and what they mean and how they apply to other parts of math later. But to begin with, we have to learn to solve them. To solve means to find 2 numbers, because there's 2 variables, that make the statement true. So I've created over here something called a table of values, which really is a little table with numbers in it. Here in this first row, I'm saying that the x is actually the number 7. I'm giving it to you. Up here it says one has to start by arbitrarily choosing a value for one of the variables. That means just sort of randomly pick a number. I did that for you. I just picked 7 because 7 is a lucky number. The object, though, is to figure out what y should be if the x is equal to 7. And so using the equation, we can take out the variable x. We don't need it anymore because we know it equals 7. We want to leave the letter y there because we don't know what it equals, and our objective is to figure it out. But basically, of course, we now just have an equation like we just finished above. We throw the 7 to the other side by transposing it to the, remember, it's the opposite operation, and we solve. Y is 5. Now, what this means is that if x is 7, y has to be a 5. They're a partnership. They're a pairing. You could write that pair without a table by writing 7, 5. Now, when you write it like that with a comma and brackets, it's called an ordered pair because the order is important. It's the x that equals 7. It's the y that comes second that equals the 5. And that is a solution to this equation. But we could do it again and again and again and again. In the second line, the y is a 3. It's the x that I don't know. Using the equation, I'm allowed to take out this time the letter y and replace it with a 3. And obviously we can see, that x must equal 9 because 9 plus 3 makes 12. Which means that if x is 9, his partner is 3. That ordered pair is a solution to this equation. If the x is a 9 and the y is a 3, 9 plus 3 equals 12. This is a solution. We could do it again because you could do this over and over and over again as long as you find a pair of numbers that make this true. And this is the main difference between an equation in 2 variables and the equation in 1 variable. Because when you have an equation in 2 variables, you're going to get many, 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 many pairs of numbers that make that equation true. In fact, you're going to get infinite pairs or infinite solutions. Every solution is a pair of numbers. So I'm going to quickly do this last one and we'll move to the new example. This one says that the y is a 4, so clearly x must be 8 because 8 plus 4 equals 12. As an ordered pair, it would look like that. If I'm filling out my table of values, then I can put my numbers in the charts and I have many solutions. I'll skip the third one so that I can move to the next example. And I'll only do 1 or 2 of these. So let's say we start with number 1, and maybe I'll do number 3. So in number 1, they're saying that x is a 10, but what would his partner, the y, be if x was a 10 to make this true? Now, once there's a minus sign, you have to be a lot more careful. You replace the x with a 10, you leave the y as a letter because you don't know what it equals, and you have to carefully solve this. Now, just watch out for your negatives, because when you transpose the 10 to the other side, what is left behind on the left side is a negative y. Don't lose the negative. You transpose the 10, it's adding 10 here, subtracting 10 there. You get negative y is negative 2. You then multiply both sides by negative 1, and you get y is positive 2. And so 10, comma 2, that ordered pair is a solution. And of course, 10 minus 2 equals 8. Let us do one more example. And again, the point of this is to illustrate how careful you have to be with all these negative signs. If we have, in example 3, we don't know what the x is, but we want the y to be the number negative 2. So when I replace it up here, you have to be very careful. You leave the x because you don't know what it is. You take away a negative 2. Don't lose that negative sign. That's part of the equation. Just because you're putting a negative number behind it, a bracket is suggested. The two negatives together, we know change to be a positive. Clearly, x is 6 because 6 plus 2 equals 8, but if we do it carefully, we see that answer. And so we get another ordered pair to this equation. There are many, 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 infinite, in fact, pairs. I did 2 examples, but really to illustrate why you have to be careful because of the negative sign. Now, when I flip this page over, I'm going to do a couple more. And the reason I'm doing these, again, is to illustrate that sometimes you can get fractions for answers. It's not a problem, so don't be surprised when it happens. We've worked with fractions. We will get some fractions as our answers, and we can have an ordered pair where one or both numbers are fractions. So what we're going to do is take the equation. This time the x is a negative 2. So I'm going to take out the x, and I'm going to put it in its own little bracket, the negative 2 in its own little bracket in place of the x. I'm going to leave the y there, and now I have an equation that I can solve. Again, you have to be careful with your negative signs. This is negative 6. When you transpose it, negative 4y is left behind. It becomes adding 6. Negative 4y equals 18. Now remember, I'm going to transpose the negative 4, but its opposite of multiply is divide. And the negative 4 remains negative because the opposite happens with times changing to divide. There's your fraction. 18 doesn't divide by 4. You don't have to try to divide it. You leave it, but it is a fraction, so you reduce it to lowest terms. I can divide them both by 2. It's a negative. I like to leave my negative in the numerator so that I don't lose it. And I have an ordered pair. The x is negative 2, the y is negative 9 over 2, and that is a solution to this particular equation. I'll do one last example. Perhaps I will do the 4th one over here. Try to be neat and organized so that you can find your work to track it in case you make a mistake. I'm going to do this one over here where I don't know what the x is, but I know that the y is a negative 1. So I write 3x minus 4 bracket negative 1. I'm going to solve this one. A negative 4 times a negative 1 is a positive 4. You really have to watch your signs because a sign error, of course, will mess up your entire answer. You throw the 4 over, it becomes minus 4. And so you have 3x equals 8. I'm going to transpose this by dividing, and I get 8/3. That's a fraction. It's already lowest terms, so I fill that out. And in this case, 8/3, comma, -1. And these are two solutions to this particular equation. Of course, there would be many more. That's basically the idea. You have to try some of the ones that we're going to assign you for homework. Remember that solutions to equations with two variables, remember, will be pairs of numbers. They're called ordered pairs. Every equation with two variables has infinite possible solutions, that is, infinite pairs of numbers. It's important that you keep them together as pairs, and the order that you put them in, should you write it with this notation, where there's a comma and a bracket, the order is very important because it makes a difference. If you switched it up, you'd be in big trouble because it wouldn't be a solution to this particular equation.